in 3.1, we talked about measures of center, and what are the measures of center that we learned? Mean, median, mode, right? We learned how to calculate that on the calculator. So today we're going to talk about measures of variation, which is another word for the spread of it. Variation is just the degree to which the data are spread out, and data can be plural as well, because you may think that doesn't sound right, but data is also plural.
Can you play Page, please?
What?
What? I'm sorry, I was trying to pay attention.
Okay. So the first type of measure of variation is the range, which is the max minus the min. You will write the range as one value. Do not say that the range is from 10 to 20. Say that the range is 20 minus 10, which would be 10. So always put the range as one number. I'm going to have y'all make a note of that, because it would be wrong if you gave me two numbers.
Why isn't it up?
Okay, so the next type of measure of variation is called the standard deviation. You might have seen this on, like if you guys have taken the ACT or SAT. It is the average distance from the mean. So you are going to have some standard deviations that are positive and some that are negative. This would be a value, like if you had a positive, like if your data was above the mean, then that would mean that you had a positive or we'll figure out later, like every single person is going to have an individual place, so that would mean you would be above the mean. If you were negative, then you would be below the mean. So for the people that are above and below, the standard deviation is calculated by taking the average distance from the mean. And so although some are above and some are below, the distance is always represented as an absolute value. Like you can't, even if you're walking backwards, you're still walking a distance. So it's like taking the positive distances or the absolute values and then averaging that number is what the standard deviation is doing. We're going to do an activity in a little bit where we're looking at different graphs and deciding, basically without gathering all of the data and calculating it, which one would have a bigger standard deviation than another. So if you had data that looked something like this, where you had high frequency on the outsides and like barely any in the middle, that would have a really large standard deviation. It would be the largest. If you had one that was just basically straight across all the way, that would be like the middle standard deviation. And then if you had one where it made a bell shape, that would be the smallest standard deviation. So looking at the graph or chart, just based on set 1 and set 2, these are the original data points. This is the standard deviation. Why is set 1 have a standard deviation of 0?
So they're all the same value.
Yeah, they're all the same value. So virtually there is no distance from the mean. And y is set to the standard deviation 10. Yeah, because basically 4 data points are away from the center. So they average 10 from the mean. So the average distance from the mean is 10. You're never going to have to calculate this by hand. The calculator will always do it for you. But before we learn how to do it on the calculator, we're just going to look at graphs and decide which one is bigger than the other, or just comparing. So you don't have this in your power or in your notes. I just added this today, but I have class A, B, and C, and we have 3 different means and standard deviations that we want to match it up with. So the first one, if you can read it, it says the mean is 46 for all of them. So they all have the same mean, but one has a standard deviation of 26, one has a standard deviation of 8, and one has a standard deviation of 16. So where or which graph, A, B, or C, would you say has the largest standard deviation? Yeah, B. Because it has like the higher frequencies on the side, short in the middle. So if it has like 2 high frequencies on the side and then not much in the middle, that's going to be the biggest. Which one has the smallest? C. And 6, so that would mean that 16 would be in the middle. That would be A. C also has the smallest compared to A because of the range as well. So in my head, I'm thinking, okay, I'm going to look at the range first. This only goes from 30 to 70, whereas this one goes from 10 to 90. So range and standard deviation go hand in hand. If a range is smaller, a standard deviation is probably smaller as well. But when you get to the point where they all have the same ranges, then you have to look at the shape of the distribution. The first one, or I guess the first 2 that I did were number 1 and number 5 because of the right and the left skew. So number 1 had a right skew, so that means the mean needed to be greater than the median. And also, I guess that only happens once, which is answer choice C. And then on number 5, it's a left skew, which happens twice, but if you're looking at where the center is, it's probably going to be higher, like around 75 versus 57. But even if you didn't know at that point, you could skip that one and keep going. So then I'm going to look at standard deviations. The next one that I see is number 4. It's a really, really small standard deviation. And I've already used answer choice C. So the next one that has a really small standard deviation is what letter? E, because it has a standard deviation of 7. So I've done 1, 5, and 4. I'm left with 2, 3, and 6. And these are all pretty symmetrical. 3 isn't perfectly symmetrical, but 2 and 6 are. And between those, I'm going to order them from smallest standard deviation to largest. So 6 would be the smallest out of the 3 left, which would be F. Number 2 would be the medium because it's straight across. And then number 3 would be the biggest because of the peaks on the side.
Why would 6 be the smallest?
Because it has like a peak in the middle.
So
The smallest out of the 3 that are left. Because all of these have the same range. Because it says in the problem that they all range from 10 to 90. Like they all have the same scale.
why is it that it peaks in the top that it makes it the smallest?
Because you have higher frequency in the middle. standard deviation is distance from the mean. So less of them are further away from the mean, whereas like in this one, more of them are further away from the mean.
Oh, okay.
So if you're thinking about like what's the average distance from the mean, there's a lot of people that are really far from the mean. But here, there aren't as many people that are far from the mean. Like it keeps getting smaller and smaller the further away you go. So I think just what you need to remember is like if it has peaks on the outsides, that's bigger. And then if the peak is in the middle, it's smaller. Smallest. And then anything in between that is going to be medium. So when we were talking about means, the population mean was the Greek symbol mu, and the sample mean was x bar, like English alphabet. The same thing is kind of true here, in that the population standard deviation is the Greek symbol sigma, which it's a lowercase s in Greek, and it kind of just looks like a little O with a curl.
What's like the actual, like where's it?
It's a lowercase s in Greek. If you want to look that up,
I need to look.
I'll try drawing it again. Just kind of looks like that. It's just like a curly O is kind of what it looks like. And then the sample standard deviation is just the letter S. So population is always Greek. Sample is the English alphabet S.
Looks like a what?
So a few important properties. You already have this one written down, so if you want to skip it, you can, but it's just how much the data values deviate from the mean, how far away they are. The value of the standard deviation can never be negative because we're talking about distance, so it's always its absolute value. It's 0 if all the values are exactly the same. Larger standard deviations indicate greater amounts of variation. So like that picture that where the frequencies are on the outside. And then outliers can drastically change the value of the standard deviation. What do I mean when I say outlier? Like what do you think of when you hear the word outlier? Yeah, like it's away from the rest of the data. Doesn't fit in. The third and last measure of variation, so we've learned range, standard deviation, and variance. Variance is just standard deviation squared. So you're going to take your standard deviation and you're going to square it. Nothing fancy about it. Population variance is sigma squared, and then sample variance is s squared. So the last thing we'll do before lunch is we're actually going to calculate range, standard deviation, and variance on a set of data in our calculator. So what we will do is take these students' scores and we will put them into our list 1 in the calculator. From here, if I want to calculate the things that I need, I'm going to hit stat, calc, enter. Keep this as list 1, nothing under frequency list, and then hit calculate. So what we know so far is the X bar is 79 and the median is 79.5. That's all we've learned so far. Other things that we can get from this is our standard deviation. So there are 2 of them because one is for population and one is for sample. So we have to discern whether it is talking about population or sample. This sigma is for population. This S is for sample, and they are different. The means are the same for both, but the standard deviations are different. because sample is like guessing what the population is, but the population is exact. So in this example, let's say that it's a population because we assume we have all of the students that we need. And so I would use the sigma equals 9.818. That's my standard deviation. 9.818. Let's just go out 3 decimal places.
How do you know it's population? I thought it was.
This one, we have all the students in a class.
Oh, so you
Yeah, it's gonna tell you. Just doesn't in this one. Yes.
So you go from stat to edit to.
You type in your data points, and then to get this, you hit stat calc 1. The other things from here, you don't have it doesn't give you your variance or your range, but for range, it does give me my max and my min. So let's say you just didn't know by looking at it. So my range would be 94 minus 62, which is what? 32. And then for variance, it doesn't give me that. So what I'm going to do is type in 9.818 squared.
How do you get back to the normal thing?
Just start typing.
Really?
Yeah.
No, okay, you hit second and click.
Or you can do that. But if you just start typing, it'll actually go to it.
96.
96.393 would be, and make sure that you're using the correct notation. The last thing we'll learn about in this lesson is called the empirical rule. So this applies to all bell curved or normal distributions, meaning it just has a bell shape.
We have to write this down.
Yes.
All of that?
So the main things that you want to write down are the 3 numbers that you have to have memorized are 68, 95, and 99.7. So if you look at the picture below, all bell-shaped or normal distributions are centered at the mean. And then if you add 1 standard deviation on each side, that means that 68% of the data fall within 1, 95 fall within 2, and 99.7 fall within 3. So for these types of questions, you will set up your bell-shaped distribution and fill in the means and the standard deviation. So we'll do one together just to kind of show you what you will draw. If you look at the picture below, so if you go out within 1 standard deviation, those 34 and 34 just means that it's cutting it in half. And then the 13.5 and the 13.5 is cutting that in half. Does everybody have this written down? Oh, sorry. I'll go back. Okay, so basically, you don't have to fill this in every time, but when you draw your picture, so example, we'll just do example 8. You're going to put your mean in the center. So my mean is 25, and the standard deviation is 5. This is example 8. And the standard deviation is 5. So I'm going to increase by 5 3 times. So I'm going to go up 3 standard deviations. So it would be 30, 35, and 40. And then on the left-hand side, I'm going to go down 3 standard deviations. So what would those numbers be? 20, 15, and 10. So the question says, between which values does 68, 95, and 99.7% fall? So for the 68%, it would be between 20 and 30. Because that's going out 1 standard deviation on each side. For 95%, it would be between which two numbers? 15 and 35. And then for 99.7, 10 and 40. Good.
Can you explain that again?
So this is just, it's called the empirical rule.
Right.
And these 3 numbers represent on a bell-shaped distribution, meaning it looks like a bell. The center is always the mean. And then the way that it's set up, the standard deviations go out. There's 3 on each side. So if you go out 1 standard deviation, that represents, like this area right here, is 68% of all the data. If you go out 2 on each side, that's 95% of all the data. And if you go out 3, that's 99.7% of the data. So basically, like if the average ACT score was a 25 and the standard deviation was a 5, that would mean 68% of the population scored between 20 and 30, 15 and 35, 10 and 40, which 40 is not possible, but
Thank you.
you're welcome. Okay, so we just did example 8. So example 9, I want you to do with your table. Actually, I want you to do numbers 9 and 10. So you're computing the range. Or I guess for number 9, you're just calculating the variance and the standard deviation. And then for number 10, you're computing the range, variance, and standard deviation. So just make sure that you're using the right symbols. So S and S squared for sample, and then sigma and sigma squared for population. They're in that black box. Do what?
You got used some of the wrong ones.
Oh. Yeah, so you just gotta be careful. And then it says sample in example 10.
Oh, I didn't do the variance.
I know what I was looking at.
So questions about this?
Just wait.
Okay. So it tells us that we have a bell-shaped distribution with a mean of 100 and a standard deviation of 15. So anytime we see this, we're going to draw our bell shape like this. We're going to put our mean in the center, so 100. And then we will go up 3, down 3. So what will the ones on the right be? What's up 1 standard deviation? Up 1 would be 115. Then what? 130. Good. And then going down, 85, 70, 55. Good. So the way that you'll see this, it won't always ask you like 68, 95, 99.7 questions. So definitely start with that, labeling 68, 95, 99.7. But sometimes it wants you to find the percentages, like it may be down 1, but then up 2 standard deviations or something like that. So if you look back, if you flip back a page on 71, you'll notice the picture has actually given a percentage to every single, like in between every single point. So how did they get the 34%?
The 68%.
Yeah, so basically I took the 68 and then I cut it in half. So this is 34, this is 34. How could you get, like, for instance, between 70 and 85 and between 115 and 130? Yeah, so I could do 95 minus 68,
And then divide that by 2.
and then take that and divide by 2. So I think that it's 27. Is that right?
Right, yeah, that's 13.
And then when you take that, divide that by 2, it's 13.5. So 13.5 here, 13.5 here. How could I get the next two between the next two? So 4.7 divided by 2, which is 2.35. And then how do I get the outer ones?
Subtract all of that.
Like 100 minus 99.7, which is 0.3. Divide that by 2. So it's 0.01 or 0.15 and 0.15. And those all represent percents. So you can either A, memorize those numbers, because you're going to be drawing this for every type of question like this, or just memorize 68, 95, 99.7, which is what I would do, and then build upon that. If you know what to do, you don't have to memorize all 8 of those numbers. Just memorize 3 of them, and then be able to build that normal curve. So it says, what is the percentage between 70 and 130? So that's going out 2 standard deviations. So that's what? 95%. The next one says greater than 130. So if 130 is here, what percentage is greater than that? Yeah, 2.35 plus 0.15, which is 2.5%. The next one says between 55, and sometimes I will use a highlighter just to kind of mark up where I'm going from, between 55 and 115. So I'm adding up 2.35 plus 13.5 plus 34 plus 34. And I have no idea what that is. 83.85. Thank you. Percent. And then I don't have this on your notes, but it shows up on your homework, and I do want to talk about it. So I added in a question. What IQ score corresponds with the 84th percentile? So what is the definition of percentile, if you guys remember from chapter 2?
Over 84%, like above everyone else, I guess. Like
Right.
You score higher than.
So basically, if you're at the 84th percentile, then you scored better than 84%. So at or below the 84%. So what score has 84% below and then 16% above? What score would that be? 115. How'd you get that?
Like just where whenever you added all those up, you got 83.8, which is 84, so you go to that one.
Perfect.
Oh, for C.
Usually,
Well,
you
yeah,
would
just adding that
subtract-
one.
You would subtract it from 100, like the ones that aren't included from 100.
Right. And so if we didn't just have that problem, it's easier to count to 16 than it is to 84. So if I were going backwards, it would be 2.5 plus 13.5. Well, that represents 16% is above. So that means 84% is below it.
Will it ever be like an unusual percentage that like?
No, it'll always be on one of these lines for right now. In another chapter, we'll learn like when it's in between those, like 123 or something like that. But right now, we haven't learned that. So everything is going to fall on a line or be on an exact number.